Hello, everyone. Welcome to Stumbles Geospatial's webinar. And today have a special guest with us. I'm sure we've joined from all across the sub-region. I know we have some people joining us from like Nigeria, some from Ghana as well. You are all very welcome to today's webinar. Data-driven insights, the power of geospatial artificial intelligence in Africa. Before we dive into it, let's take note of a few housekeeping rules. This webinar is being recorded and the recording will be made available after the webinar. If you have any questions as the presentation is going on, feel free to ask them in the Q&A section or in the chat box. These questions will be answered during the Q&A segment. If during the period you're having the Q&A session, you feel you are more vocal and you'd like to unmute yourself, you can raise your hand and your mic will be unmuted. A feedback form will be shared for your comments and assessments of this webinar to help us to improve and to know what you'd like to hear of in the next one. For our agenda today, we are going to look at what is AI. I'm sure Geo AI. We've all been familiar with artificial intelligence. It's been making the news, but now we are going to focus on geospatial AI. What is it? And then we'll look at what does it do, especially in our context, in our continent, in Africa. There will be a live demonstration from our speaker, after which we'll have our Q&A session for you to ask your questions, ask for clarification. And in the closing, you can also let us know how well we are doing and what you want to hear in the next webinar. Now, before we begin, Stumbles Geospatial is a leading geospatial innovations company with presence across West Africa. We have physical offices in Ghana, in Abuja, and in Lagos. We have partnerships with Esri to provide ArcGIS technology. Trimble, we deal in GPS devices and data collection devices. For NV5 Geospatial, we also offer or provide NV remote sensing technology. And with Wintra Gen 2 drones, we also have that available for organizations, individuals, for all their geospatial and data collection needs. In addition to that, we also offer professional services, trainings, after-sales technical support, and bespoke geospatial solutions. We do have collaborations with organizations and NGOs as well to make an impact in our industries and in our society. Our speaker for today is a geospatial analyst at Aya Data. Aya Data is an end-to-end AI and data science company focusing on building and deploying computer vision and natural language processing products to solve difficult problems and deliver exceptional value. Aya Data builds everything from data-powered farm management platforms to chatbots, as well as providing data collection and data annotation services, a portfolio of international clients, including major global enterprises. They are active across Africa, Europe, and Asia. At their core, they are committed to delivering excellence in AI development with a global reach and world-class AI solutions. Among their products is IRGrow, an AI-powered farm management platform that optimizes yield, cuts costs, and provides tree analytics, health assessments, and yield estimation. Aya Speech, another one of their products, uses AI-powered speech translation to bridge language gaps, specializing in low-resource languages for effective communication. Now, ladies and gentlemen, I want you to help me welcome Theodore Chloe Alafeya Kwakumi, our wonderful speaker for today. She's a geospatial analyst at Aya Data with specialty in geospatial data analysis. Welcome, Theodore. How are you feeling today? Hi, Theodore. I see
I'm sorry about that.
Again.
Yeah.
Oh, no worries.
I wasn't
glad
allowed
to have you
unmute my mic, so yeah. Hi everyone. Sorry about that slight technical difficulty. My name is Theodore Alafia Kwakume, as you see on screen, and it's nice to be with you guys today.
Taylor, it's lovely having you here with us as well. Thank you for honoring our invitation. Before you start, I'm sure we'd love to hear a little bit about you, how you got into this geospatial industry, where you started from, and what your motivations were.
Right. That's actually a funny story. I didn't study geospatial data analysis or anything geospatial in school. I did biomedical equipment technology. But then how I got into this was during my national service at IAData. See, I kept noticing a group of people, they were quite mysterious, that they weren't labelers at the time, because that's what I was doing. I was an annotator for IAData at the time, and I was super curious about what they did. And it turns out that they were the data science team, and I was interested because I kept asking questions, trying to make small talk and gradual interactions. And IAData really encourages learning. And since I'd already picked up some Python, I decided to go for an internal internship that they were offering. So even though I felt way out of my depth, I decided to try. I took the test, I did the presentation, and I somehow landed a geospatial data science internship for the rest of my service. It was tough at first, but my manager was amazing. He believed that, if I could learn to code, I could learn anything. And honestly, yeah, I've had incredible support and coaching from the team, and really everyone is awesome over here. So, yeah.
Yeah, wow. Motivation, not just personally and internally, but from your supervisor as well. I'm sure we can all relate because believe you me, starting from school, it can be stressful. So I can't imagine kind of being dunked into it from the very beginning. But that's lovely. That's lovely. So with what you've been doing in your geospatial analysis, I'm sure at some point you kind of integrated artificial intelligence into what you were doing, your analysis with your workflows. So at this point, especially in the job market, a lot of people are concerned about AI taking over their jobs, compromising on their livelihoods and all that. So from your perspective, working with this, how did you get to the point of fully embracing geospatial artificial intelligence?
So I understand that Geo AI is basically the intersection of geospatial science and artificial intelligence. So it's a combination of map-related information with very smart computer programs. It uses these programs to understand patterns in Earth's data. And like many AI technologies, it's a powerful tool that complements human capabilities, or should I say it augments it. It doesn't replace them entirely. So let's think of Geo AI as a smart helper and not somebody that's going to steal your job. It's really good at doing the boring, repetitive stuff or the grunt work, right? Like sorting through maps, pictures, processes that are repeated. You have to go through them over and over again. And that frees up people to have time to do the really important things. And that is what requires human creativity. So understanding that's what made it easier to just use these tools, really, because that's what they were made for.
Yes, that's amazing. Using these tools because that's what they were made for. They were not made to take over our jobs, but rather to help us to be more effective. I believe this is a good point to delve directly into our presentation. Let me stop sharing my screen. Okay, over to you, Taylor.
Lovely. All right, can everyone see my screen?
Yes, we can.
Okay. All right, hello everyone. I'm excited to share with us today how we at IAData are leveraging AI to drive development in West Africa. in the space of geospatial data science. iData uses geospatial data with AI to address critical development challenges in agriculture. Like you've heard Josephine previously explain, we build rather and deploy geospatial AI solutions in Ghana. We use drones, bespoke AI models, and custom data management and visualization software to transform efficiency in farming, forestry, and climate projects. But before we get into that, we'll be looking at the fundamentals of geospatial data and the AI revolution that's reshaping its analysis. We'll also highlight real-world applications and touch on the landscape of AI implementation in our parts of the world. Right, so what is geospatial data? It is fundamentally information that is tied to a specific location on the Earth. It is the where in data analysis. It's the foundation for understanding spatial relationships and patterns. Now, this data comes in various forms, each with unique characteristics and applications. It is primarily split into categories based on use, and the main types are vector data. Now, this represents geographic features using points, lines, and polygons. We also have raster data, a grid of pixels or cells where each pixel has a value representing information, such as elevation or land cover. And this can be gotten from satellites or drones. We have attribute data, which is non-spatial information that is linked to vector or raster data that provides details about the features in these other types of data. And then we have point cloud data, which are collections of 3D points with X, Y, and Z coordinates, often obtained from LiDAR photogrammetry methods. Now, if we're wondering now about what artificial intelligence is, at a basic level, it is about making computers do things that normally require human intelligence. Now, here are a few concepts in artificial intelligence. We have narrow AI that performs a single task. Basically, these types of artificial intelligence tools are created to do just one thing. And then we also have general AI, which is it has human-like intelligence, right? It doesn't just work for one thing. It cuts across a broad range, but then because it doesn't work for one thing, we can't really use it in a specific area, if that makes sense. And then we have machine learning that learns from data without explicit programming. We've got deep learning, a subfield of machine learning that uses artificial neural networks. And these networks are basically human brains. It's like we're getting the systems to think like us, and they handle complex patterns. Right. So what was geospatial data like before AI, or geospatial data analysis before AI? Now, before the development of modern GIS software and remote sensing technologies, geospatial data was traditionally analyzed using manual and analog methods. Now, these methods relied heavily on paper maps made by cartographers, where features like roads and rivers were traced onto the hand-drawn maps. For field surveys, compasses were used for angle measurements, chains and tapes for distance measurements. And these and a few other tools were the sole instruments used for field surveys and land measurements. Now, for large-scale mapping, photos were taken from an aircraft, as that was the primary remote sensing method at the time. And to view terrain in 3D, a stereoscope was used on the overlapped photos. Spatial data analysis was done manually or with early mechanical calculators, all to interpret geographic patterns. And as for their filing systems or storage systems, they had paper records, ledgers, and filing cabinets, where hard copy atlases were used for referencing locations. Now, these methods had limitations, some of which are that it was time-consuming and labor-intensive, such that data collection and analysis could take months or years. The accuracy was limited as the manual methods and manual calculations introduced errors. Maps could not easily be updated like digital GIS layers, and there was no way to efficiently search, filter, or analyze data beyond basic visual inspection. Now, what is the purpose of geospatial data analysis? It's a powerful tool that allows us to understand the world in a spatial context. The whole point, really, is to gain insight, a meaningful realization obtained from analyzing data, observations, and experiences. It allows people to see patterns, relationships, and trends that are not or may not be immediately obvious. And one of the purposes is to understand spatial relationships. The world is a complex system, and many things are interconnected in ways we don't always realize. For example, changes in climate patterns can affect agricultural yields, which in turn can impact global economies. Crime rates, for example, could surprisingly correlate with proximity to certain landmarks. Now, these are some of the relationships that geospatial data can uncover. And in deciding where to situate residential areas, recreational centers, or commercial developments, the proximity to transportation and environmental constraints are factors that are considered in order to make good decisions. Take traffic signal timing, for instance. As random as it may appear, it is influenced by analyzing traffic patterns and identifying congestion hotspots. In the area of public health, tracking the spread of diseases is quite a bit of a problem that mapping outbreaks have solved. For resource management, if we consider the cost of fertilizers, pesticides, herbicides, they can be quite a significant expense, especially for the large-scale operations. And water, which is one of the most crucial resources in agriculture, is quite limited. Now, precision agriculture techniques that rely on geospatial data can optimize yields and improve efficiency. And based on current trends and relationships, it is possible to make predictions, and we can forecast future spatial patterns. For example, flood risk areas. These are some of the things that this is something that can be predicted. So in essence, any problem that involves location or spatial relationships can potentially be addressed using geospatial data analysis. Now let's take a look at the role of AI in geospatial analysis. Within the domain of computer vision, various models exist, with convolutional neural networks being particularly effective for image-related tasks, right? In trying to teach a computer to see things, we must first realize that a computer sees a picture as a grid of numbers or pixels, and each number represents the color of a tiny dot. So it's like looking at a spreadsheet filled with color codes. But the problem is, if you just fed those numbers directly into a regular neural network, it wouldn't understand the shape of things. So the first step for a CNN, a convolutional neural network, is to find specific patterns. It highlights parts of the picture that have something interesting. And by doing this over the entire picture, the CNN can find where these patterns are located. The first layers of the CNN find the simple patterns, and the later layers combine those patterns to find more complex shapes. And eventually, the final layers can recognize the whole object. So this is an example of unidentified palm trees, the first image, and the one that overlaps it have the palm trees within bounding boxes. Practical application of computer vision. Now, to truly understand and anticipate changes across our world, machine learning with algorithms like random forests, support vector machines, and regression models now empower us to predict and model complex spatial patterns. For example, in this conceptual image on the screen, we can see that it shows terrain that is rugged and has steep slopes. And that suggests geological instability, which is conducive to earthquakes. Now, the bright orange or yellow parts of the image often represent regions with significant tectonic activity, and that's a primary indicator of earthquake risk, and therefore, it is more likely that an earthquake will occur in such areas. There are different machine learning techniques that are used in the analysis of geospatial data. We have supervised learning that involves the training of algorithms on labeled data sets, where the input data is paired with the correct output. So it's like mix and match. You have a label for a cat, and then you have the image of a cat. So if the computer wants to identify a cat, it can tell now that this is what cat looks like, right? And we also have unsupervised learning, and that is used when the data is not labeled. You haven't defined anything. Essentially, the algorithm finds patterns in the data it is presented with. Now, some examples of these algorithms, we have the classification algorithms, and these models predict categorical outcomes. For example, the algorithms I mentioned earlier, random forest, support vector, and neural networks can classify land cover types based on the features that are extracted from satellite imagery. The model learns from training data to distinguish between the different classes, different parts of the Earth, based on spatial attributes. And we have regression algorithms. Now, these models predict continuous outcomes. Techniques such as linear regression, decision trees, gradient boosting can be used to make estimates. They learn the relationship between input variables and the target variable. And that allows for predictions on data that we haven't seen yet. For instance, this scatter plot shows the correlation between nutrient concentration or presence and indices from different image bands using a backward regression method. Now, the dependent variable, in this case, the nutrient content, is mapped to the independent variables, the indices. And the most impactful independent spectral variable that explains the relationship better than any other spectral band can is chosen. Now, that will then be used to predict nutrient content for other plants that we don't have any nutrient data on. Another is the clustering algorithm. Clustering essentially means bringing together data points that are alike, forming distinct groups or categories based on shared traits. Now, this technique is super handy in lots of areas. If you would like to sort customers, analyze pictures, or find things that don't really fit a certain pattern, this is the tool for you. Techniques like k-means and hierarchical clustering can segment geographic areas based on similarities in attributes. And this is useful for identifying regions with similar characteristics. In the area of urban planning or resource allocation, this is mighty helpful. Now, for deep learning tools, particularly recurrent neural networks, they excel at handling complex tasks that involve sequential data. Right? They can capture dependencies in sequential data, and that makes them ideal for time series analysis. Here, we're trying to teach the computer to understand sequence or order. And in doing so, we must acknowledge that the regular neural networks treat each of their inputs as independent or isolated. And because of that, they don't remember anything from the past. They do not use any of their former inputs in the rest of their processing. And this is a problem if you're trying to understand something where the sequence matters. So RNNs have a loop. It's like a little memory that lets information pass from one step to the next. And essentially, the output of the network at one step becomes part of the input at the next step. So imagine you're walking along a path and recording the elevation at each step. This creates a sequence of elevation values. And RNN can learn the patterns and trends in your sequence. And once they have done that, or once it has done that, it can use its memory to predict the elevation at the missing points. It can remember how the elevation changes from one point to the next. So it's like the RNN says, based on how the elevation has been changing so far, I think the elevation at this missing point should be such and such, whichever value. Also, there are certain techniques tailored for geospatial data. We have the geographically weighted regression. Now, this method accounts for spatial heterogeneity by allowing relationships between variables to be different across space. A practical example is if you're looking at house prices in a city, We know that the things like the size of the house, the number of bedrooms, and the neighborhood affects the price. Normally, we will just say, or we'll make one big equation to see how these things affect price for the whole city. That's a regular regression. But this particular regression is smarter. It realizes that what adds value in one neighborhood might be different in another. So a bedroom might be worth more in a fancy area than in a less expensive one, right? And that makes it allows us to see the local differences and not just the overall average. And that makes it cool, really, because now you get a much more detailed picture of how things change across a map. Then we have spatial interpolation. To explain this, I'll be using this example of having thermometers scattered across a field, right? Each of these thermometers gives you a reading. But the thing is, you want to know the temperature of everywhere in that field, not just where the thermometers are located. There are two common ways to do this. We have kriging, that uses statistics and the patterns in your data to make the best possible guess. And we also have inverse distance weighting. It's a simpler way that says, okay, the closer you are to a thermometer, the more its reading matters. So if you're standing between two thermometers, the temperature reading of that point that you don't know will be a weighted average of those two thermometers that are close to it. We have integration with geographic information systems as well. Machine learning models can be integrated with GIS platforms like Esri's ArcGIS to enhance geospatial analysis. Now, this integration allows for spatial data manipulation. GIS tools can pre-process and manage your spatial data, and that makes it easier to feed into your machine learning models, and the results of the machine learning analysis can be visualized on maps, like you see in this small video over here. This is an example of, this is the Esri's ArcGIS dashboard. That's a small snippet of it. Right, so it provides intuitive insights into spatial patterns and trends. Now let's take a look at AI-driven geospatial solutions in West Africa. Since we've had a look at geospatial data, artificial intelligence, the purpose of everything, and then how these AI tools can be used in the field of geospatial data. And let's see how AI data is practicalized in that. So in the sector of agriculture, AI Grow, which is a product of AI data, empowers growers with AI-driven insights to optimize farm management, to enhance productivity, and address challenges proactively. Now, with real-time data and automated monitoring, growers can make precise data-driven decisions to maximize their yields. Now, in West Africa specifically, there are many challenges in agriculture, but then we've been able to identify 4 of the biggest challenges. One of which is yield gap and low productivity. Now, yield gaps refer to the difference between the potential yield of a crop and the actual yield achieved by farmers. Low productivity means that farmers are producing less food per unit of land and labor and resources that they could be producing. Now, these contribute to food shortages and increased reliance on imports. We also notice that they spend too much on supplies like fertilizer, and that cuts into their earnings. There aren't enough workers, and that increases costs and makes it hard to run farms, especially the big farms. Lastly, farmers don't have enough information on what's happening on their farms, and that leads to poor decisions and lost opportunities. Now, iAgrow combines AI, drones, satellites, and mobile tech to deliver insights for a range of tree crops. It enables growers to optimize yields, track their health, and improve the efficiency of the farms. Some of the solutions in iAgrow is the tree count and blank spots detection. Now, this uses a tree count model. And that is a computer vision solution where our in-house annotation team curated labeled data sets on which the model was trained to identify crop from an aerial photograph. In addition to counting trees, we identify areas called blank spots where new trees can be situated in order to optimize the use of their land. Another solution here is the comprehensive health analysis. Our health analysis report utilizes vegetation indices to determine the health status of each tree on the farm. We use a regression model to determine the correlation between nutrient levels and spectral signatures. This allows us to detect foliar nutrient content. For the yield analysis solution, we use a statistical model that delivers foresight into yield estimates and insights on the gaps in the yields on the farm, or the farm yields. And we also run classifications on your terrain to ascertain topography. And this is useful in assessing slope risk thresholds, or even if the farm would like to situate culverts because of flooding, to divert the water away from where the trees are located. You need to know what your topography is like. Now for fresh fruit bunch counting and grading, here we're essentially saying that, okay, let's move away from paper records and manual methods. Take the logs of the farm operations to digital systems, right? This picture of this man taking a photo, what looks to be a photo, is him using our image detection model to identify which of the bunches are ripe or rotten. Now this lets us see how much is being harvested, who is doing the work, and how well they're doing, all in real time or near real time. And this allows the farms to work smarter, to waste less, and to get more fruit. So how do we make this possible? We collect aerial data from drones or utilize satellite images. We run that data through our proprietary AI models for crop monitoring, and we visualize the results on a geospatial information system, like ArcGIS, and then we share this with the client for them to make their decisions with the right data. So let's take a look at a demo to bring these concepts to life. Let's transition from theory to practice. This right here is an oil palm monitoring dashboard, right? It shows an overview of plantation, or two sites actually. These colorful dots on here are geolocations of each tree. But before we got the data onto this, we had to run, like I explained earlier, we had to run the data we collected from these farms through our models. And how do we get it onto this dashboard? ArcGIS has a web map function where you're able to upload the results of your analysis, right, into layers. And with that, you're able to manipulate or decide how you want to present your information to your client or whoever it is that you are providing the service for. So these are all the layers that are on the dashboard. Here you can edit the styles as you wish, right? So we have the count, the blank spots, the health status, the crown distribution layer, drone imagery, we have the terrain view, and we put that all here, and we created a dashboard, with that information. Now the functionalities I was explaining when I was talking about GIS systems, the functionalities are numerous. Here we can see the layers, right? And you're able to toggle these on or off, whichever one you'd like to see, whichever one you'd like to not see. So let's start with the count, the health distribution. Over here, you're able to see only a select number or a select category. You can turn that off or on so that when you're presenting this, it is easy to go through the numerous insights that you have gotten from your analysis. On this side, we have a block summary where we're seeing an overview of data on these two sites. So this is block one, where we see the size, cultivated area, the uncultivated area, year of production, and every other thing that you need. Now to show you what the blank spots look like, let me turn that on. So the purple dots is the count, and then the white dots is where plants are supposed to be situated. Now, if you notice the pattern, I mean, we can tell that there are gaps in here. For an oil palm plantation, there's usually a planting distance of, let's say, 8 to 9 meters. Now, our blank spot model takes that into consideration, and it provides areas where you should plant or situate new trees without compromising your planting distance. Right. Okay. So now that we have seen the use of these innovations that have been facilitated by AI, let's come to the challenges of implementing AI in Africa. So the first one I'd like to talk about is the data accessibility and quality. So high quality, consistent, and readily available geospatial data is not always there. And this includes data on soil conditions, weather patterns, and crop health. There may also be significant gaps in data coverage, particularly in remote or underserved areas. And this is very common when you're trying to acquire satellite imagery from the satellite image providers. Most of the times, if you're dealing with smallholder farms, you would search, and then they would end up telling you, oh, we don't have any coverage on this area. It's challenging, really. The next thing I'd like to hit on is the technical capacity. Again, we're in Africa. We know how our internet access is, unless you have Starlink. Yes, so reliable internet access is essential for geospatial AI applications. But many areas, rural or urban in West Africa, lack adequate connectivity. Farmers may also lack access to the necessary hardware and software. There is a shortage of skilled professionals with expertise in geospatial AI and agriculture. Many farmers have low levels of digital literacy, and that makes it challenging to implement the digital solutions. Now, this might be tailored to agriculture, but trust me, this cuts across every other sector that you might want to apply Geo AI into. A prominent one is limited awareness. Many farmers, policymakers, the stakeholders may not be aware, or they aren't aware of the potential benefits of geospatial AI, and hence they are less likely to adopt these technologies. Now, this slows down the overall progress of modernizing the agricultural practices. Another one is the funding and investments. Yes, it is a great technology. It's making things work, but then there's a cost to it, and this cost could be a barrier for many, but it is worth it in my opinion. Now, on the side of the opportunities, we have, like I've spoken extensively on, agriculture, food security, where precision agriculture, like what iAgro offers, can optimize, farm processes, yield, and contribute to effective management practices. If you'd like to venture into livestock management, you're able to track livestock movement and health using GPS and remote sensing, and this could improve animal welfare and prevent disease outbreaks. If you'd like to venture into environmental monitoring and climate change, you have natural disaster management. You need geospatial data. You need to analyze that, and then you can use AI tools in this. Take, for instance, the floods that keep coming back, right? We also have the EUDR. By using satellite imagery to track deforestation and land changes, authorities can better enforce environmental rules and implement sustainable land practices. Side note, iAgro also provides a service for EUDR. In the area of urban planning and development, West African cities, as we know, are growing fast, and that causes problems like bad traffic and housing. Demographic data can be analyzed to help city planners make smarter choices. In fintech, we make a lot of transactions, right? A combination of these transactions and location data creates valuable data sets for AI to learn from. And this allows for the analysis of economic activity through patterns like mobile money usage. And because a lot of people use mobile money, can easily use AI to help with location-based problems without having to build everything from the ground up. Now, in the area of improving healthcare access, geospatial AI will be able to analyze key data to reveal areas lacking healthcare access. And this would allow for strategic placement of clinics and services, which are crucial in regions with limited infrastructure. So we've taken a look at how AI with geospatial data are really making a difference in West Africa, from helping farmers, keeping an eye on our precious environment, urban planning, and all that. Now let's look at charting the future. What's next? What can we do? The key takeaways that we have learned here at IAData to effectively leverage AI-driven geospatial analysis in West Africa. We have seen that specific competencies and resources are indispensable. So we have employed AI-infused methodologies. The computer vision, I keep mentioning, machine learning, deep learning tools. These are things that we have put in our methods. And you can apply this as well, but just make sure that it fits your specific mapping needs. We have high fidelity geospatial data sources. We've been quite, focused on getting our hands on good data, because, the better the quality of your data, the better chances you are at getting good results. And most importantly, tap into local know-how. That has been huge in our experimental efforts, because we're only providing the solutions. But if we do not understand the problem and hear the problem from those that are going through it, we may not be making relevant solutions. And lastly, we need to do this ethically. So keeping the data safe and using the AI tools responsibly, that is non-negotiable. Now, if we want to really see this tech thrive, here are a few things we should be thinking about. Getting better data. Like I said, good data in, the greater your chances are at getting accurate results. Also, we should invest in local capacity building to develop a skilled AI workforce in our continent. Growing our own tech talent, training and education are key. We also have to make sure that we have the right infrastructure. So we should invest, or should I say, establish clear ethical guidelines and data governance frameworks in conjunction with our computing power, connectivity. These are some of the things we need to start thinking of fixing, right? And lastly, we should really be thinking of transfer learning to make the best of limited data. Rather than thinking of building everything from scratch, use the existing systems, fine-tune them, and make them suit your purpose. So looking ahead, how do we make sure that Africa is right there in the middle of this tech revolution? So I think it's about staying curious and always learning. We know that tech changes fast. And this is not me saying, go ahead, chase the latest trends. No, keep yourself abreast of what's going on. What's the tech space like? What can be adopted? What do we need to let go of, right? Also support local innovation. Let us grow our own tech solutions, right? Let us produce things that those from outside would also want to come and participate in. And in doing so, teaming up is a great way to start. We need to build strong cross-sector partnerships that will drive impactful solutions. Let us also focus on solving real problems and not just playing with the tech, because that's where we will see the real change. The future of West Africa's development lies in the intelligent application of geospatial data. And together we can make that future a reality. And by embracing these technologies, we can also unlock a new era that has data driving the development, which will transform the continent for generations to come. Thank you.
Thank you, Taida. Truly insightful presentation. Indeed, focus on the real world, not just on the tech, because that is how we will make the true changes. Wonderful presentation. Thank you. At this point, we are opening the floor for questions. If you have any, you can share them in the chat box. You can also raise your hand so that we unmute your microphone. I know we have people here from across industries, government sector, academia, nature and conservation, agriculture. And so feel free, any question at all you have, would love to help you to truly understand this and maybe even share a few more specifics on how you can improve in your own sector as well. So yes, any questions for Taylor? All right. Bismarck asked earlier if a recording will be shared, and yes, I can assure you the recording will be shared by email to everyone present here. You can also keep an eye out on our social media channels, especially on YouTube. Turn on notifications, subscribe if you can, so that you can receive the notification of when the recording is available. Okay. Taylor, if you don't mind, I would like to just ask you perhaps like what your team was made up of in maybe doing the or using AI in Ayago, right? Because I know a lot of us are working in teams. We need to know, okay, who does what in this particular workflow.
Okay, so the data science department has the geospatial sector, or should I say the segment geospatial. We have split it into machine learning, right? And then we have our cloud engineer. Right? So the geospatial guys are responsible for fundamentally understanding the problem and discovering what tools will work. So we work with the ML team closely because they're the ones that are responsible for making these models, right? And then because we implement clouds, or we use cloud services for faster scaling and basically efficiency, we work with our cloud engineer to now put this whole pipeline, to make a pipeline for the whole solution. And we also have our product lead, and then our Scrum Master that's responsible for keeping the team, in sync. So that is what the data science team is made up of. That's for IAGROW. Now we also have the IS speech side. They're also machine learning engineers that are handling the speech aspect of our services.
All right, it sounds like a well-oiled machine to bring us this, should I say, revolutionary technology. I mean, IAGROW, it will do so well in helping to increase our agricultural productivity, especially in this time of, climate issues and food insecurity. We have a question in the chat from Isa Mustafa. He's asking if the presentation will be made available. I think we will liaise with Taylor to get that to you. So if you need the presentation, kindly share your emails with me in the chat so that we take note of them and then send them to you when they are available. I see a hand up from Diamond. Hello, Diamond. Let me unmute you. All right. Diamond, so can you hear me? Your mic is allowed now, so you can unmute yourself and ask your question. Hello, Diamond, can you hear me? Okay, so while she's working on her mic, I see a question in the chat from Ms. Lokolo. I hope I'm pronouncing it right. He says, thank you, Taylor, for an insightful presentation. Given such great strides and advancements in technology, How do you think GIS programs in university should be revised? I would assume it is much easier for a software engineer to easily learn GIS concepts than introducing programming later on in the life of a GIS graduate. So, what is your take on that?
Okay, if I get the question right, you're wondering if programming should be brought first and not later in the course of the study, right?
I believe so. So she's asking at which point, since it seems to be come at a intersection of so
Yeah,
many
much
special.
easier.
Yeah.
So I
Okay.
would say no knowledge is wasted, really. As for the revision, I would not be able to tell because I didn't study it in school. But then saying that a software engineer is able to understand it faster or better may not necessarily be the case. You that have gone through the process of studying all that you need as like your foundation may be able to have a better insight than someone that just knows how to use the tools. It's one thing to know how to use the tool, it's another thing to know what to use the tool on. So I don't think any knowledge is wasted. Maybe in the revisions, they could probably adapt it to the changing, should I say, landscape. Because the problems that we're getting now aren't the problems that we had before. So if any revision should be made, it should be based on the issues that are prominent now. So what does a geospatial data scientist need to know in order to solve the current world solutions?
Okay.
I hope that's okay, cool.
Yeah. Miss Nopolo, can you let us know if you are okay with that? If your question has been answered.
I I see one. I see someone asking, how do you go about explaining the importance of Geo AI insights to local people who may not understand the technology fully? Do you take the approach where you explain to them that they have nothing to lose? Or if not, what do you do? So it's rather than make it an umbrella thing, I think actually explaining the use cases to them, something that they can understand. So just simply saying they have nothing to lose doesn't reassure them in any way. Explaining why this tool or this geospatial data and its analysis can be beneficial to them. It's easier when you speak in someone's language, right? So I wouldn't suggest that you just tell them they have nothing to lose. What you do is understand their problems. Again, the foundation of geospatial data is finding patterns and relationships. If you're able to find a relationship between their issue and geospatial data solutions, trust me, you wouldn't have an issue or you wouldn't have a problem explaining to them what they need to know to understand the technology.
Thank you, Taylor. Diamond, I think you said you still have issues with your mic. Do you mind typing it in the chat so that at least we get to hear your question? So let's see. The next question: what are the relationships between geospatial data analysis and scientific computing data analysis? I think these should go together. So what is your take on that from the programming side and the geospatial side, Taylor?
Okay, my mic is muted. Okay, cool. So actually I think both disciplines, they at their core, they extract meaningful information from data, and they use computational methods to identify patterns, trends, relationships, and they both heavily rely on programming languages. They use algorithms and models to process and analyze large data sets, I would say. So yes, you are right, they should go together. The thing is, you can pair geospatial data analysis with almost any field, really. I'm yet to see one that absolutely doesn't need any sort of data analysis in the geospatial area. So you are right. These two can go together. They should go together because they're very similar at their core.
These two should go together and they can go together because they are similar at their core. Derek is asking, can open source software such as QGIS be used in combination with AI to retrieve insights such as non-open source softwares? Sorry, let me take that again. I think I missed something. Can open source software such as QGIS be used in combination with AI to retrieve insights as much as non-open source softwares are used?
That's an interesting question. I use QGIS a lot too. There are quite a few limitations, right? For example, the dashboard that you see, it is infused. It's one of ArcGIS's should I say products or capabilities. You don't have to like move your data from one platform, or let's say when you're done analyzing, you don't have to move it from let's say your local disk to a different place. You can do all of that. Okay, let me explain this in a different way. So if you're thinking of dashboarding, having a web map, and then using what's it called, displaying or visualizing your results on QGIS, you can basically do all of that, but then having that in a place that allows you to do all these things together, I would say is the primary difference. Sure, you can use open source softwares like QGIS, but then there are slight limitations. As slight as they might seem, it'll make a whole lot of difference to the people that you're catering to. So that is, from my little experience, that is one of the limitations of the open source softwares. They allow you to get a start, to understand what it is you need to do. But if you actually want to, should I say, be on par with what's going on, like the trend in this, the words aren't coming, but if you basically want to provide a solution that aligns or matches with the ones that are already there, that people are patronizing. So I think it's more or less about visibility. QGIS is not a bad software. Open source is good. If you can use open source to do your analysis, to provide your solutions, do go ahead. Not everything has to be paid for, but understand that there are advantages to these paid platforms over the open source ones. You would see that all the time. You have access to, for ArcGIS again, you have access to pre-trained models for land classification for different purposes. On ArcGIS, you have tools that allow you to run classifications, all right. Yes, but then the ones on ArcGIS that I have tried, they are specific to let's say Sentinel-2 data. You have Landsat data, but then on QGIS you have to make those tweaks yourself. So I hope I've been able to paint a picture with this small description. So open source softwares such as QGIS can be used with AI. It may not be as much as the non-open ones, or the ones that you paid for. It might just be a longer method for you to get to a point that you can arrive at quicker. I hope that makes sense.
Yes, so thank you for that, Theodore. So if we get you correctly, open source software like QGIS can be used, but it is greatly limited in that regard.
There are some limitations to it, yes.
Okay, wonderful. I think we have two more questions and then we close, but then I would like to remind everyone that to get the recording or to be notified when the recording is ready, you can subscribe to our YouTube channel. The link is in the chat. You can also let us know what topics you would like us to cover in the next webinar. Also let us know on what we are doing well, what you'd like to see more of. And the link to our webinar feedback form is also in the chat. All right, so the penultimate question from Juma. what is the relationship between, oh wait, I think it's already been repeated. The relationship between geospatial data analysis and scientific computing data. So Juma, we've covered that already. And Diamond, your question. What tools must I master to be able to land a career in geospatial data analysis field?
Okay, that's a fun one. Um, Learn how to use the geospatial information systems, the system softwares. Like we've mentioned, QGIS is one freely available that you can start with. Programming languages, Python, it's everywhere. It is indispensable for geospatial analysis because you have access to libraries like GeoPandas, Shapely, Stereo, GDAL. These are valuable tools that can help you in your processes. There's also R, SQL, or SQL, as a lot of people like to argue about. Visualization, yes, knowing how to use these tools. But I would like to hammer on, rather than not just the tools, but then skills that you should develop as well. So being able to think spatially, understand and interpret spatial relationships and patterns. This is something I've had to employ a lot or use in almost everything. So it's being able to relate one thing that you're doing or learning to another thing that you probably have learned or something else that you know. It improves the ability to spot patterns, right? Data management, organizing, cleaning, managing large data sets, analytical skills, being able to, and this is important actually. You have to apply statistical and analytical methods to get useful information from your spatial data, being able to identify and solve the problems using the tools that are available to you. And last but not least, communication, being able to convey what you're saying effectively to, whether it's just somebody that knows what you're talking about, somebody that doesn't know what you're talking about. There'll be less friction if you work on your ability to communicate what it is you're doing, what you're trying to solve, your thoughts process. Yeah.
Excellent. So Juma says he's made a little bit of clarification to his question, but then I'm sure you've covered it in your presentation about the challenges in incorporating or fully utilizing Geo AI in Africa. So for Juma, I believe if you'd want more clarification on that, maybe Theodore, if you're open to it, you can have a conversation on it, because truly it's one of the challenges in Africa. I do believe there are quite a number of symposia and conferences looking at trying to gather stakeholders to bridge these gaps. But before we close, finally, Theodore, do you have any, should I say, words? Any final words?
Words, right. Well, it has been quite an opportunity to converse with, like minds that are interested in this geospatial space. I do not know it all. That is something I was taught to use in my learning process, right? Even though I may know something, there's no harm in knowing it again, because once you go over, you could get a fresh perspective, right? So in getting to this point that I'm at, I have come to realize that all the fields are connected. You can basically provide a solution with the most unobvious group members, or should I say team members. It'll be shocking what you do once you embrace collaboration, really finding where you can provide a solution to this person's problem and how that could affect a totally different person, right? So and learning, I've come to appreciate that fact. I've come to appreciate working teams, being able to continuously learn with people that push you to learn. So my final words would be, wherever you are at this point in your journey, do not lose that value of being able to be taught. That is something you must protect at all costs. Be teachable. Thank you.
Thank you, Theodore. I think at this point you deserve a round of applause, a standing ovation even, because truly it's not, should I say, easy, even being the groundbreaker in something like this, but you've taken the time to take us through sharing your experience, sharing other data's experience, answering our questions about how we can, get started with education, maybe even how we can overcome some of these challenges. Truly, we do appreciate your time here with us, Theodore. Thank you so much.
Thank you. Thank you too.
And thank you to our wonderful audience for staying with us, being with us. Once again, Sambo's Geospatial dedicated to providing innovative geospatial solutions. We'd like to hear how we can also help you in your field, in your capacity building with whatever education needs you have. Give us a call, reach out to us. You can visit us on our website. Once again, we have a presence in Ghana, in Accra, and in Nigeria, in Abuja, and in Lagos. Feel free to reach out to us. Let us know how we can help you, how we can also provide these tools that you need in your workflows and in building your capacity to reach Taylor's level, Thank you all. I bid you all a very wonderful day, and so we meet next time. Thank everyone.